Light is the message from the stars. It reaches across the void, strikes the green leaf, and gives rise to life as we know it. In the garden, light is not merely a source of warmth. It is a fuel, a signal, and a command. Plants do not simply enjoy sunlight. They are shaped by it, moved by it, and utterly dependent on its presence. Let us begin with a natural source, the sun at 93 million miles away. Our star bathes the Earth in a constant stream of photons. These packets of light energy strike the surface of leaves and initiate photosynthesis, the process by which light, carbon dioxide, and water are transformed into sugar and oxygen. Within the plant's chloroplasts, chlorophyll molecules absorb light primarily in the red and blue wavelengths. Green light, by contrast, is reflected, hence the familiar color of most foliage. Using the absorbed energy, the plant splits water molecules, releasing oxygen and capturing electrons. These electrons fuel a chain of reactions that convert macroscopic carbon into glucose, a simple sugar that powers growth and development. Light does not only feed the plant, it also instructs it. Plants measure day length, photoperiod, to determine when to flower, when to seed, and when to rest. Long day crops like spinach and lettuce bolt under extended summer light. Short day crops like chrysanthemums bloom when autumn nights grow long. Still others, like tomatoes, are day neutral, responding more to temperature and age than to hours of light. In nature, intensity and duration vary. A full sun plant, such as corn or melon, requires 6 to 8 hours of direct sunlight daily. Shade-tolerant species, such as mint or chard, survive with far less. But even among shade plants, light remains essential. Without it, chlorophyll fades. Stems stretch weakly toward the source. Leaves grow thin, small, and pale. The plant, though alive, becomes hollowed by deprivation. Now let us turn our eyes indoors, where the sun's reach falls short and gardeners look to a modern substitute, the grow light. Grow lights attempt to replicate the wavelengths most important to plants: blue light for vegetative growth, and red light for flowering and fruiting in early years. Incandescent bulbs were tried, but they produced more heat than photosynthetically useful light. Fluorescent tubes followed, gentler, cooler, and more efficient. But today, the most effective and customizable solution is the LED. LED grow lights emit specific wavelengths with minimal energy waste. Blue-rich LEDs are used for seedlings, encouraging compact leaf production. Red-rich LEDs are introduced during blooming to prompt flowering. Full-spectrum LEDs combine both, providing a balance closer to natural sunlight. Still, grow lights differ from the sun in more than appearance. The sun provides ultraviolet and infrared radiation, which affect pest resistance, vitamin synthesis, and plant structure. Sunlight arrives from all directions, filtered through air and reflected off surfaces. Artificial lights are directional and must be carefully positioned. Close enough to nourish, far enough to avoid scorching intensity, duration, and coverage. All must be managed by the gardener. Light exposure is measured in PAR, photosynthetically active radiation. This indicates how much usable light is reaching the plant. Too little and photosynthesis stalls. Too much and tissue damage or photoinhibition may occur. Indoor growers often rely on timers, delivering 12 to 16 hours of light per day for most vegetables, while allowing a dark period for metabolic recovery. But one must not be fooled by brightness alone. A standard household lamp, no matter how white, may fail to provide the correct spectrum for plant growth. Conversely, a compact violet-blue LED array may appear dim, but deliver exactly what a leafy green requires. Ultimately, light is information. The plant does not see it as we do. It absorbs it, measures it, stores it, and obeys it. So whether your garden stretches beneath an open sky or glows quietly beneath a basement lamp, remember, every leaf is listening, every stem is reading, and the language they understand best is light, pure, silent, and radiant with potential.